Hi everyone, my name is Jason Koo. Today I'm going to quickly go through Neo4j's Python driver and just show you how to get started with it. Before you can run the driver, you need to have an instance of Neo4j up and running, whether it's a cloud instance, Docker, local desktop. Now today I'm going to show off using desktop. Each instance can have multiple databases, so the way you could create them is by pressing on the GUI here, create database with a GUI dash database. Okay, so I'm going to open this up and you should be able to access the different databases through this left drop down menu. You can also do :use and the name of the database, and it'll switch between the databases. You can also create new databases, so you just do create database. Let's call this test. And then click here. You can see this is spinning up. Okay, well, let's see if I can just jump in here. Use test. Okay, so this is available. And I can see here, this is a new database, which is empty. And since we're here, to show you how to get rid of databases, let's use GUI database. I can do drop database test. Let's see, if I go back to here, I can do the triple dots and I can do a dump, which is pulling down the data, or remove it here. Okay, so that's just a quick rundown on the different ways you can add databases, switch to databases, and remove databases. Okay, so now I can jump into the driver and show you how this works. So what I'm going to do is just show you that I've got an empty folder here, and I'm using Windsurf to develop this. I'm going to spin up my virtual environment first, and then add Neo4j dependency. And then here in the main.py file, we're going to copy and paste that earlier example code. Now up here at the top, there are going to be 3 pieces of information minimum to connect with a Neo4j database. One is going to be the URI. This is set up for localhost 7687 for connecting with a desktop instance. And then auth, username, password here. I'm going to replace my password with the marginally stronger ABCD. So what I'm going to do here, just so I can walk through this easier, is I'm going to actually move these credentials down to here. Because the way the sample code is set up is it will spin up a context manager for the driver and then run these functions, which runs a query for each friend, 2 friends that you want to connect for this. So, okay, so I'm just going to run this first so you can see what the data looks like. So uv run main.py. So in the database, we can see we've got the records that we're expecting, right? Arthur, Nose, Merlin, Lancelot, and Guinevere, which is matching the setup here, right? We're adding a friend between Arthur and Guinevere, Arthur and Lancelot, Arthur and Merlin. Great. What is happening here is we are putting in the URI and the auth credentials here to initialize the driver. Now the auth is a tuple, right? Username, password. And the one other argument you would very likely add is the database. All right, so here you can give it specifically Neo4j or example the test. So you can see here in the add friends function here, they actually are here. You can also specify the database. Notice here that database has an underscore suffix. So how the execute query API works is you pass it a string, which is the cipher query, and any parameters added afterwards are just name parameters for passing data into the cipher query. And any parameter that's part of the higher level execute query function is suffixed by an underscore. What I'm going to do here is actually copy and paste this over so it's easier to see. Oop. An alternative to doing these parameters is you could just give a map, right? So let's say we've got, Arthur, friend of Guinevere, and we just want to run that. So here, instead of the name parameters, we just replace it with params. Here, this does need to have parameters underscore equal. Guinevere, actually, let's choose a different knight here. What was it, the Green Knight? Let's do that for now. Forget his actual name. All right, so if I run this, Go back to the database. I can see he also knows the Green Knight. So you can use maps and pass that in to the execute query function. Okay, so taking a closer look at this Cypher query here, we were using merge command for creating records. Now there are actually two Cypher statements you can use for creating nodes. It's merge or create. Create will always create a new node with the parameters that you pass it, but merge will only create a new node if there is not already an existing node with these values, right? Label of person and the name of, in this case, Arthur being passed in. Now, this particular setup is perfectly fine for inserting small pieces of data, but if, say, we wanted to put in a list of dictionaries into this, this may not be the most optimal, right? Like constantly running single queries. You can, in fact, pass a whole list of dictionaries into a query and run an unwind statement. So let me show you what that looks like. So I'm going to remove this parameter. And what I've done is I've asked Claude to generate me a list of company employees and who they work for. So I can just take this copy, or take this list, and I'm going to put it here. Yeah, I'll put it on the outside here. So I've got a list of dictionaries, company map, just has name and works for. So what I can do is a multi-line statement here. Actually, you know what? Let's call this entry. So that means what we're doing is we're taking each individual dictionary and we're going to process each one within this list, right? So each entry will have two key value pairs, name and works for. So here we will create a node for a person with their name. No, we'll keep that. So with entry P, we first want to create that second person, right? So name, entry, works for. And if they actually exist, then we will create a relationship between the person and the second person. We're just going to put in a where statement to filter out. So we're going to do where entry works for is not null. Yep. Okay, so only continue if that value is not null. Okay, so now if I run this and check the database, I need to switch to test. Now if I run match in, so this is one Cypher statement for returning all nodes within a database up to, you know, X number of records that can fit in the memory. So Alice Smith is the leader, and we can see these other folks are working in these smaller teams. All right, the next thing I want to show you is what you get back if you do a read statement. Right? When you run this query, it will return you a tuple of information. It will be the results, summary, and keys. I'll just write over this. So I'm just going to do a simple match statement. So match is for signifying basically your starting position within the graph. But here I don't have a lot of folks, so I'm just going to return all the person nodes. Okay, and then just to print out the statements. Okay, so we can see here, we get a list of node objects. In the summary, we get a result summary object, and keys, we just get a dictionary of values. So if you want to see more information on what's involved with these objects, you can go to our docs. So here we have a record object, a result summary object. Now, the things that you would be most interested in is the records. That's usually the information that you want to extract. And if you look down here, one of the properties for a record is a .data API. So this will convert that record into a map for you to use. Okay, so if I run this now, you can see the output as dictionaries. The return statement can dramatically change what the results output is going to be. So here I just returned P, which is the node, and so it just gives me just just the one property value for it. If I wanted to say get around that, and I just say like I just want the name of people to return, and I can even give it a explicit string to use, right? So here, run this again. You can see down here. So the key name equals Alice Smith, and that's it. It's in the map. Okay, before I move away from records, this may be of interest to some folks. So results 0, print f first record. So if your output is going to be pulling back nodes or relationships, you will get slightly different record levels. So let me run this real quick. So here you'll see it's a record object, and you will notice here you have an element underscore ID and a frozen set of labels. Oftentimes nodes can have multiple labels, and if you want to grab all the associated labels with that node, you can pull that frozen set out, and the element underscore ID is a unique internal identifier for each node. So if for some reason you don't want to set up your own sort of UUID property, which I do recommend, you could make use of the element underscore ID. To extract it is a little counterintuitive. So say I wanted the element ID of that first record. All right, so to get it, you do like results, the index of that record, and you're going to grab the value of a particular key. So here it's this value, and then you put in the name of the key. P was the name of the node that we had defined in the cipher statement, and then just element ID. And if you wanted to grab that frozen set, it's very similar. Let's do this real quick. And let's call this labels, results 0, value P. So you can see here, we've got the element ID string and the frozen set, which you'd probably want to change into a normal list to work with. Okay, so those are extra pieces of information you can extract from a records object. Okay, so the last thing I want to show is the summary. This is the docs on the ResultSummary object, and of interest oftentimes is the counters. So the counters here will tell you how many nodes or relationships were created, edited, maybe deleted. And this can be useful if you want to double check if a cipher statement had done what you had expected. But to get this information, you will need to run some sort of query that actually edits data. So let's say we want to find the person who is the leader of this organization and just label them CEO. We're not. So what I'm going to look for is a person who does not work for somebody else. And we're going to set their title to, I don't know, CEO. And then, yes, return that. Just interested in the summary this time. Boop. So the summary has a counters property, right? So we'll do counters equals summary counters, and I'll just print that out. Okay, I'm just gonna run this. So you can see here, summary object here, and then contains updates. Yes, one property was set. So that is maybe some interesting information you may want to make use of out of the summary object. All right, so that's a real quick walkthrough of how to get started with the Neo4j Python driver and some basic cipher to get you up and running. Good luck, happy graphing, and I'll see you in the next one.